Keeping your code clean and tested are the two most important development practices. In Flutter, this is even more true than with other frameworks, because on one hand, it's nice to hack a quick app together. On the other hand, larger projects start falling apart when you mix the business logic everywhere, which is so simple to do with Flutter because even the UI is written in the same programming language in which you write the actual logic. Even state management patterns like BLoC are not sufficient in themselves to allow for easily extensible codebase. And this is where we can employ clean architecture and test-driven development. As proposed by our friendly Uncle Bob, Robert Cecil Martin, we should all strive to separate our code into independent layers, and that's precisely what you are going to learn how to do in Flutter in this course. Hello, welcome to ResoCoder, where you are getting prepared for real app development by building better, faster, more stable apps. So subscribe and hit the bell if you want to grow your coding skills and learn about clean architecture in Flutter. Let's start out with the completely finished app, which you will have built by the end of this course. We're gonna build a number trivia app because, believe it or not, there is actually a numbers API which provides some nice trivia about numbers. So we can input a number here, for example, 1, 2, 3, and then search for the trivia. Let's search for yet another number, for example, 42, right? And we can also get random trivia. This is another endpoint on the API. And then also this app will cache the gotten number trivia from the API so that if we should not have internet connection, so if we enable airplane mode here and come back to the app and get random trivia, it's not going to get us any new trivia, it's just going to display the lastly gotten cached trivia. Of course, once we enable internet, we'll be able to again get new trivia just like before. This app has all of the core components which you will be working with in your own apps on day-to-day basis, such as getting data from API, local cache, error handling. For example, if we input ABC with a keyboard, you can do that. So input that, it says invalid input, the number must be a positive integer or 0. It has like input validation and all that good stuff which you should have in production apps. And as for state management, we're gonna use BLoC, but you do not have to use BLoC because, as you will see later on in this course as we progress, it will become apparent that the state management which you choose is really almost inconsequential because everything will be handled in different layers. So the bottom line is, do not worry if you do not want to use BLoC in your apps, you do not have to. Clean architecture works with any kind of state management pattern, even something like simple change notifier with a provider will be just fine. And be sure to check out the written tutorial from the link in the description if you want to really go through this at your own pace, because this first part will be more about theory behind clean architecture, because we cannot progress forward in this course without first understanding the core concepts of clean architecture and why it's actually useful and why it does things the way it does them. And in the written post accompanying this first part, you have all of that available and you can go through it at your own pace. So let's first take a look at the clean architecture as it was proposed by Uncle Bob. So it looks something like this, and really it doesn't tell us much when it comes to Flutter because like what is a controller, what is presenter, gateway, what is all of that. It just spits out a bunch of abstractions in our face, and all in all it's a bit abstract, pun intended. Also, while the essence of clean architecture remains the same for every framework, the devil definitely lies in the details, and we will have to adapt this general clean architecture to Flutter. So lo and behold, because now I will introduce to you the ResoCoder's Flutter clean architecture proposal. Yes, it's an official thing now, which will demonstrate something, should I say, more important than just some dependency flow and the onion, it will show you the data and call flow. It may seem like there's a lot to comprehend here, but do not worry, we are going to get through this slowly one by one. So the core thing here is that the whole app, or should I say every core feature of an app, like for example, getting number trivia, will be divided into three parts, three layers: presentation, domain, and data. And actually the app we are building, this number trivia app, will have only one feature because it's a simple app. The only thing we do here is to get number trivia. So we'll have only one such division into folders. So let's actually create these presentation, domain, and data folders right now. So let's open up VS Code. We are starting off with a completely new project here, and I will enlarge this so you can see the folders even better. So inside the lib folder, we are going to start off with creating a features folder, because every feature, as I said, will have its own folder, which will be divided into presentation, domain, and data. So let's just create the folders and then I will explain everything more in depth. So the feature name will be simply number trivia. You can have feature like login or registration or something like that. You can have feature settings and so on. If you have those things in your app, we have just one screen, number trivia, and that's it. In here, we want to create domain. Then another folder will be data. And the final one will be presentation. And with this, we have the basic structure, the most high-level structure of our app created. Of course, just having features is not enough, because what if, for example, you have something which can be used across multiple features? Let's just say that you have also settings feature, and even over there you want to do input validation. Well, input validation, for example, just checking if the inputted text doesn't contain any numbers, that's not really feature specific. It can be shared across number trivia, settings, whatever. That kind of functionality will go into the core folder. All right, now that we have the basic folder structure, let's continue on with this awesome diagram. Let's take a closer look at the presentation layer, which is actually what you are already used to in Flutter if you've done any kind of a Flutter development before. So presentation is comprised of widgets. So this is where all of the pages live. For example, number trivia page. And this is also where you will have your own custom widgets. And then it also has something called presentation logic holders, which is either a BLoC, a change notifier, or really anything which you would classify as state management. You can even go the good old stateful widget route, but I would really recommend you to at least go for change notifier. But I really think that BLoC is the best state management option for Flutter out there. But really, presentation logic holders, they're not all that important which you choose. We are going to choose BLoC for this app. And as opposed to what you may be used to, these presentation logic holders, so BLoC or change notifier, will really not do much by themselves. They will only delegate all of their work down to use cases, to the domain layer, and so on. BLoCs or change notifiers will be really lean classes. They will not have a lot of logic. At most, you will do some really basic input validation inside of them, and that's it. Everything else will be delegated to the next layer, which are use cases or the domain layer. Before we continue with the next layer, let's just jump into VS Code and let's create the structure of the presentation folder right now. So we're going to create new folder under that. It's gonna be called BLoC. Again, you can use anything you want. And then pages, and finally widgets, which will be just widgets which we do not want to have directly inside the page because it would just clutter up the UI code. The next layer we're gonna take a look at is the domain layer. As you can see in this call flow arrow, the call flow will happen from the upward layers, so presentation, down. So this presentation logic holder, for example, a BLoC, will delegate its work and call use cases which are from the domain layer. So what is actually the domain layer? This is the inner layer which should not be susceptible to the whims of changing data sources or porting our app to Angular Dart. It should be really platform independent and actually independent of anything else inside the app. It will contain only the core business logic, which will be executed inside use cases, and then also business objects, which we are going to call entities. And by the way, use cases are classes which encapsulate all the business logic of a particular use case of the app. So for example, we will have use cases for getting concrete number trivia right here, which will be executed whenever we press the search button here. So this is get concrete number trivia use case. And then another use case in our app is get random trivia. So those will be two classes, get concrete number trivia and get random number trivia. Of course, in our app, we will not have a lot of business logic, and even the entity which will hold the number trivia, actually, they are gonna be pretty lean classes because we are not doing much in this example app. But in your own projects, when you are building something more substantial, the domain layer is where the bulk of the code will be located. And if you've been listening to me carefully, I've said that the domain layer should be completely independent of every other layer. Well, I know that you probably cannot tell much just from this diagram, but it seems that the domain layer is independent of the presentation layer. But here it gets kind of fancy looking because the repository is seemingly inside the domain layer and also in the data layer, right? So what's up with that? Half of the repository is domain and half is in data? No, that's not how it works. What this nice fancy gradient on the repository signifies is that the repository class is on the edge between data and domain layers. And to allow for the independence of the domain layer, we are going to do something called dependency inversion. So what is dependency inversion? I know that you may be getting some goosebumps because they're just scary words, but dependency inversion is in essence very, very simple and straightforward. It's just a fancy way of saying that we create an abstract class repository, which will define a contract of what the repository must do. So for example, in our app, we will have a repository which must provide us with random trivia and concrete number trivia. Those are the two things which the repository just must do. And that goes into the domain layer. The domain layer does not care how the number trivia will be gotten. It just cares that it will be gotten, right? This is all possible with an interface, or because Dart does not support interfaces, we have to use abstract classes. And then the other side of the coin, or in this case repository, is inside the data layer. The data layer will define how the data will be gotten and managed and all of that. We're gonna get to that in just a short while. But the important thing is that the repository in the data layer will implement the abstract class, so it will have to conform to the so-called contract, so that domain can really not care what's going on behind the scenes. It just knows what kind of data it will always receive from the repository. In this case, it will be the random number trivia and concrete number trivia. So let's create a folder structure, shall we? Inside VS Code, the domain layer will have 3 subfolders: entities, which will be the number trivia entity, which will simply hold the text of the trivia and the number of the number trivia. Then we will have also another subfolder, repositories. This is where the contract or the abstract class of a repository will go. And then also the last folder is use cases. So use cases are get concrete number trivia, and as you can see, there was some server failure now, so error handling works correctly, but I don't know why there was a server failure. But anyway, now we have 42. So this is the concrete or get concrete use case. And we also have the random use case. And let's now move on to the data layer. As you already know, it contains repositories, which implement the abstract classes from the domain so that they will have to just fulfill the contract defined by domain. And then it also contains remote data sources, local data sources, any kind of data sources obviously go into the data layer. Usually you have one data source for getting remote data from the API, and then you also have another one for getting local data. In our case, we will use shared preferences to cache the data locally. And local data sources are also where you would have your, for example, GPS, location code, and all of that good stuff. Data sources do not have to just operate with databases, they can also operate with the underlying platform or device. And the repository is the brains of the data layer, because this repository will decide when to cache, what to cache, when to get data from the remote data source, when to get data from local data source. So for example, if there is no internet connection, we definitely want to get data, the cached data from local data sources. And you may notice that repositories output entities, which kind of makes sense. And again, entity is just the number and the text of the number trivia, really simple in our case. But data sources do not output entities, they deal with something called models. And this nomenclature is really not all that important. It doesn't matter how you call these things, it's just that you know what those names mean. And the reason behind having models is that transforming raw data, which is for example JSON, requires some conversion logic. Because we cannot work with JSON in our app, we have to convert it to Dart objects. But now let's think about this. We definitely do not want to put our JSON conversion logic, so to JSON and from JSON, as we are all used to, for example, from build value or JSON serializable, we do not want to put those conversion methods into entities. And why is that? Well, entities should be completely platform and data layer independent. So for example, if we switch from JSON to XML or to some binary data craziness, we do not want to change the domain layer at all. We only want to change the data layer when something data related changes, but the domain should remain untouched. Therefore, these models will be simple classes which extend entities and add some functionality on top of them. And because they are subclasses of entities, we can then simply cast them into entities, and the repository will output the entity which does not have any additional functionality or fields added on top of it. In the number trivia app, since we do not have anything really difficult to do, models will have only toJSON and from JSON methods. But if you are storing something locally in an SQLite database and for some reason you have to have the ID inside the database stored inside the model, you can also add some custom fields to the model, not just methods. In our app, the remote data source will perform an HTTP GET request to Numbers API, which is simply numbersapi.com, and all of these links and all of that which I'm explaining here is also available from the written tutorial, so definitely check that out. But here is numbersapi.com. This is the API we will be using. So as you can see, we can get random trivia, right? This is what we are doing from within the app. So this is what the remote data source will do. It will perform GET requests. And then we have also local data source, which will simply cache data using the shared preferences package. And then these two data sources will be combined, sort of, in the repository, which in the case of the number trivia app, it will do just a simple thing. It will check whether or not the user is connected to the internet. If there is internet connection, it will always prefer to get fresh data from the remote data source. If there is no internet, it will get the cached data. And it will also have a simple caching logic, which is that we always cache everything as soon as it's gotten from the API, so that if there is no internet connection, it will always return the cached data, the last cached data to be precise. Alright, so let's now create the folder structure even for the data layer, because the things below are not actually a part of our app. These are some external things. We do not care about them. It's not a part of our code base. And the data layer will be comprised of data sources, models, and finally, implementations of repositories. So the repositories folder in data will hold the implementations, and the repositories folder in domain will hold the abstract classes or interfaces, which are the contracts which the repositories implemented in data must fulfill. And again, this abstraction is necessary so that the domain layer can be completely independent of every other layer. Alright, so this first part of this test-driven development clean architecture Flutter course was really theory heavy. That's because something like clean architecture requires a lot of explanation, because after all, you cannot just start building a house without first planning how the house will look like. You have to have at least some basic structure, some basic drawings in place. And these drawings were laid down in this first part. So in the next parts, we are going to actually get coding and doing test-driven development, and we're going to start off with this domain layer. So if you do not want to miss that tutorial and more other tutorials like this, definitely subscribe to this channel and also join the notification squad by hitting the bell button to make sure you grow your Flutter skills, because here on ResoCoder I am determined to provide you with the best app development tutorials and resources out there. Also, make sure to check out the written tutorial available from the link in the video description to go through all of this at your own pace. You will highly benefit from reading the written tutorial if you want to learn the most about clean architecture, which I'm sure you want to do. If this video helped you with clearing the concepts of clean architecture, give it a like and also share it with other developers who will surely benefit from this too. Follow me on Instagram, I go under the name ResoCoder everywhere. Leave a comment if you have anything to say, any suggestions or questions. Stay tuned for the next part in which we are going to finally start writing code, doing test-driven development, and see you in the next video.